What makes you, you? And what makes me, me? What makes the matter around us different? And how do we think about the world around us? Consider when you light a wax candle. Now consider if you ignite a piece of paper. Why do these two materials react so differently to a flame? To answer these questions, let's explore chemical properties and chemical change. Hello, friends. So we're still in the unit of matter and change, but this lecture's topic will be on chemical properties and changes, as well as the law of conservation of matter. In our last lecture, we explored physical properties and physical changes. So for example, we looked at how maybe a gem might have a certain hardness or color or luster, right? So these are all physical properties that describe the substance. We also looked at physical changes. These include things like an ice cube melting, so solid water changing into liquid water. But at the end of the day, it's still water, right? We also looked at how chopping a piece of wood is a physical change. The wood has certain physical properties. It has, a certain texture, a certain odor and color. And when we chop it in half, it's still the wood. So this is it undergoing a physical change. Let's explore chemical properties and chemical changes, though. Let's switch gears and take some notes. Again, we are still in the unit of matter and change. And this particular lecture is going to focus on chemical properties and changes, as well as the law of conservation of matter. First, let's remind ourselves of what the definitions are of a physical property and a physical change. So a physical property. This is a property, so a characteristic of a certain substance of matter that we observe with our senses. Again, maybe you have a piece of jewelry and it has a certain color, it has a certain texture. We can feel it, we can see it. Even certain types of metals have certain types of smells. Second part of a physical property is that it is determined without destroying the matter. Again, if you're holding that piece of jewelry and describing it, you're not magically destroying the piece of jewelry in your hands. You're observing, you're describing it, and at the end of the day, that substance, that item is still the same item. What about a physical change? We define a physical change as happening when there is a change in the size, the shape, or the state of the matter. So again, size, think of chopping the piece of wood into smaller pieces. Shape, we're also changing the shape of that shape of wood. The state. Remember last time that we briefly introduced the three main states of matter. So this is solid, liquid, and gas. We'll get more into detail on this later, but for now, I want you to recognize that if you switch from a solid to a liquid to a gas, or vice versa, it's a physical change. Think of that ice cube. Think of water. All right, the second criteria for a physical change is that no new substance has formed. Again, what you start with is what you end with, the type of matter. If I start with an ice cube, that's still water, just solid water. And if I hold it in my hand and it melts to a liquid, it's still water. No new substance has actually formed. Let's compare these physical identities to the chemical properties and chemical changes of matter. So I'm going to make a divider line. Let's define what a chemical property is. What a chemical property is it tells us if the substance, if that item reacts with something else. So it indicates how a substance reacts with something else. I think one of the easiest go-to examples for this is if you put Mentos into a bottle of soda, right? It explodes. So the Mentos definitely has a reaction to the soda. The second criteria for a chemical property is that the matter will be changed into a new substance after the reaction. Again, think of that Mentos with the soda. Once it reacts, that Mentos is gone, right? And it has, bubbled up fizz, created carbon dioxide in the process. You could imagine that if these are the criteria for a chemical property, that a chemical change is really just turning this into a verb, into the actual action itself. So let's define what makes a chemical change. And you may hear, instead of the word change, the word reaction. Because we're taking matter, we're taking stuff, we're making it interact with the world around us, around it, to produce something different. So, the definition for a chemical change or a chemical reaction is that there is a change in the original chemical or physical properties. This is kind of a dry definition. It's easier to visualize with examples, which we'll go into in just a minute. But again, this is saying you start with one thing, you react it with something, and you change it in some way. Second part is that a new substance is formed. Again, there's some actual change that occurred to the matter itself. You might be wondering at this point, well, how do you really know if a change occurred? And there are 4 key indicators for chemical reactions. And I'm going to actually abbreviate reactions RXNS, so reactions, okay? First clue, first indicator. There is a transfer of energy. This might seem pretty abstract, right? Like, what is energy? How do we define it? What does this mean? Think of your stovetop. So, you have maybe a gas stovetop or, like an electric stovetop. But when you're cooking food, you're using that stove to transfer energy to your food, to cook it, to change it in some way. Another example might be if you have a campfire. Those logs are pretty obviously giving off heat, right? If you have an active campfire. Well, you stick your marshmallow in the campfire and it starts to bubble and turn a different color and cook. This is a transfer of energy. Second indicator, and we're going to see some examples after this, okay? Second example is a color change. Again, just talked about that marshmallow, right? So we go from that, the white marshmallow color to like the brown. Maybe you like to set your marshmallows fully on fire, so it's very charred. We see that color change. 3, production of gas. We can actually think of this like a new substance being formed, right? There's gas being given off. Think of that Mentos in the soda, right? It's giving off a lot of carbon dioxide. That's a gas. Production of gas. 4, formation of a precipitate. Now we're going to define what precipitate means. Precipitate is, let's write it down here, a solid that forms out of a liquid mixture. This is actually how you get cheese curd out of milk. The cheese curd settles and you can actually sieve and filter off that cheese curd. In more of the chemical sense, you might think of, adding some liquids together. And when you add some liquids together, maybe a solid forms at the bottom. That is our precipitate. Let's move on over back to our slides so I can show you some cool examples. Let's explore chemical properties. Let's say you have a canister of gasoline. Hopefully y'all know that it is very, very flammable. It can catch on fire very easily, so if you ever have to work with this, please be careful. That's a chemical property. Gasoline is flammable. If we also look at a rusty bike. So the fact that this metal can rust is a chemical property. Now let's look at some chemical reactions. I think these are a lot cooler to look at. So again, we have 4 common indicators. Transfer of energy. Think of bread in a toaster oven. That toaster oven is supplying heat, supplying energy, and, it toasts your bread. And, maybe you like your toast a little less done. Maybe you accidentally burn your toast and there's a lot of smoke everywhere. Chemical change, transfer of energy. What about color change? That's also a common indicator. Let's say you have a pool in your backyard and, you have to make sure the pH level, which we'll get into later, is just right so that you can actually go swimming and, not burn your eyes. So you use a pH strip that indicates a color change depending upon the pH. This is a chemical change. Production of a gas is also a common indicator. So this is an Alka-Seltzer tablet in water, and you can see all that gas being given off. And at the end of this reaction, that Alka-Seltzer tablet is going to be all used up. We also talked about the formation of a precipitate. So this is a really cool chemical reaction here involving silver. So a silver solid is actually coming out of solution and precipitating down to the bottom. But I know that we're not always working with, like chemicals. So we can also think of this precipitate formation using cheese curds. So these curds fall out of, the terminology is falling out of solution in the milk. And you can take a strainer and strain that cheese curd out. So I want us to go through a few examples and think of, is this a physical or chemical change? Ice cream melting on a hot day. What's happening to the ice cream? Is it changing to another substance? Is one of the 4 key indicators for a chemical change there? Maybe, maybe not. This ice cream is melting. It's going from mostly solid to liquid. So that's a state change. This is a physical change. What about, y'all, I'm so excited to show you this later on. What about if I have different metals, like actual samples of different metals on a table, and I light them up with a match, and they all produce different colors, which is so cool, and I'm so excited to show y'all this later. What is this, a physical change or a chemical change? Well, it's definitely giving off a color, and it is flammable. It can undergo that change. And actually, cool thing, this is how fireworks work. They use different metals to give different colors. This is a chemical change. Have you noticed one of the trends with chemical changes versus a physical change? Many chemical changes are irreversible. Once it undergoes that change, you can't just bring it back. Like, again, ice cubes, right? Liquid water, freeze it, go back and forth. Let's think of if you have a bunch of jelly beans and you mix the different colored jelly beans together. This is a physical change. They're still jelly beans, they're just mixed. And if you had the time, you could sort them back out. That is a reversible change. What about an egg? What about cooking an egg? So you're frying it, it turns into a fried egg or scrambled eggs, however you're preparing it. Can you uncook an egg? No, you can't. A lot of chemical changes are irreversible. And that's one of the indicators that it's a chemical change. Now that we've discussed how we can discuss matter in both a physical and chemical sense, in our next lecture, we're going to really start talking about how to classify substances based on these properties. So, yay, more into chemistry. Until then, though, I want us to be able to think about the bigger picture of how we talk about matter. So let's draw a handy-dandy flowchart. At the top, we've got properties of matter. So we can go in either the physical route or chemical route for describing this. But what is the question, the main question we ask, that determines if it's a physical or chemical property? Is this property determined by changing the identity of the substance? So this is my first major question. So we're going to go this way first. So, is this property determined by changing the identity of the substance? If we say no, what would that be? A physical or chemical property? This would be a physical property. Remember, we're observing it, we're characterizing it, and we're not changing the item we're working with. Okay, what about if we do change the identity of the substance? So that's a yes. This would be a chemical property. All right. Next up, I'm going to keep looking at this chemical property side and say, okay, what is a chemical property? What are we really asking when we're defining this for a substance? What we're really saying is, how does the substance react to whatever we're interacting with? Some of the common things you'll see include air, acid, base, water, or really just other chemicals in general, right? So this is what defines a chemical property. Basically, does it react? Let's look at our physical properties. All right. If you remember from our last lecture, we could subdivide physical properties into a couple different categories. So let's say we're looking at an item and we want to describe its physical properties. Does the property depend on how much substance we have? Let's draw a little box. I'm gonna get another color. Let's get green. So for physical properties, remember, we can think of it in terms of, sorry, my dog is scratching her collar, intensive or extensive. So if the property, my flowchart's going to look a little funky because I'm working with a smaller screen, y'all. I apologize for that. So if the property depends on how much substance we have, so that's let's make that orange. Yes. Then it is an intensive physical property. This includes characteristics like color, or the melting point, or the odor of an object or substance. And if the answer is no, then we have an extensive property. So this is like mass, length, or volume. And we're going to discuss this later on in more depth, just like a lot of stuff. We're going to go into more detail. Yay! Why do you think knowing if a property is intensive or extensive is important in not just the chemistry lab? Maybe you're a forensic investigator and, you're trying to figure out, what is this substance? But maybe you only have a little bit of the substance to work with. Well, for an extensive property, you might have to use up whatever little bit of that substance you have. But an intensive property, you could use a little bit of that substance to test out what is that material. So it's helpful to be able to categorize these properties. I want us to revisit the example I had at the beginning of this lecture. So the candle burning and the piece of fire burning. And I want us to think about which one was a physical change and which one was a chemical change. So thinking of that flow chart and those characterizations of physical versus chemical. Let's look at the candle first. And when I'm asking about the candle, I'm asking about the wax, not the little wick, okay? I'm looking at the wax. So I'm sure you all have seen a candle burning. You know that that wax turns to liquid, so there's a state change, and that if you collect that liquid wax, it can re-solidify. So again, changing state. Think about what change that is. And then think about the paper. So instead of a piece of paper, I have a picture of a campfire here, right? Both are paper products. The paper and the wood. When it gets set on fire, is that a change of state? What actually happens to the papers, to the fibers of it? Can you undo it? Can you take those ashes and turn it back into paper? So hopefully, by the end of this lecture, you're able to tell me that for the wax, it's a physical change. And that for the wood burning or the paper, it's a chemical change. Yay! And I want to show you a really cool example of a chemical change in the next slide. This example really shows why in a chemistry setting, when you're working with these different types of chemicals, it is so important to know what some of these chemical and physical properties are. All right. This is a chemical known as T-butyl lithium. It is pyrophoric, meaning that it spontaneously combusts in air. And it's actually a pretty useful chemical for certain types of research. So you could imagine that the safety precautions for this are really strict. Actually, a lot of chemistry departments use this as the example for safety because unfortunately a few years ago a graduate researcher actually caught on fire and died from this chemical compound. So again, it's important to know what these properties are so you can be safe. I want to show you what it actually looks like in air. All right. So they're taking it out of the bottle into the syringe, and now they're pushing the liquid through the syringe into the air. So again, I want to show that to you without me talking. That's pretty metal. That's pretty insane and pretty cool that something can do that, right? So again, there's safety in knowing these properties. We're starting to build this foundation of how we look at the world around us. And the world around us is not static. There's change always going on around us, whether it's a physical or chemical change. Let's start to tie together the pieces of before and after. In a previous lecture, I brought up the concept of alchemy and how people used to actually try to turn things like pennies into gold. And, I can't even make this penny turn into a quarter, let alone gold. So there must be some underlying chemical kind of guidelines, right? That allow or prevent from certain types of reactions from happening, right? So again, I can't go from a penny to gold. One of these important laws, actually, is the law of conservation of matter. You might have heard of this in one of your other classes. This law is related amongst so many different sciences. And what this law states is that during any reaction, so again, I like to abbreviate reaction as RXN, the mass of the products. So next time we'll delve more into the definitions of like products and reactants. But for now, just think of products as the stuff you get at the end of a reaction. So during any reaction, the mass of the products is equal to the mass of the reactants. And the reactants is the stuff you start with. Simply put, this says that you can't make something from nothing. For example, let's say I'm making cookies. And I know that one batch of ingredients, I can't spell, is about 25 cookies. If I want to make more cookies, let's say I want to make 50 cookies, I know that I'm going to have to use 2 batches of ingredients. I'm going to have to double the amount of flour I use, double the amount of whatever other ingredients. Y'all already know intuitively from interacting with the world that you can't just magically have something from nothing. You know, as much as I wish I could just be like, cookies appear in my hand, you actually, what you start with equal the amount of what you start with equals the amount of what you end with. Speaking in terms of chemistry, the law of conservation of matter is so incredibly important. Again, what it's saying is the total amount of stuff we put in equals the total amount of stuff we get out. As we start to describe chemical systems more in terms of chemistry vocabulary, we're going to start to see that, again, we can describe these systems in terms of ins and outs, reactants and products, what we start with and what we end with. So this concept carries through in all of these ideas, and we're going to start to see more of the details of how we apply it as we get more into the curriculum.